in B, right? If this is A, this is B, then 1, 3, 5, 7, 11. These are in this part, right? This region, which is part of only A and not B, this section, right? Okay. Then B minus A.
Then screen is not visible.
Oh, is it? Okay, just a second. Please confirm if it is visible now.
Yes, ma'am.
No, ma'am.
Ah, thanks. Okay. Okay, then let me re-begin it. Okay. Okay. Let A and B be two sets such that A minus B is equals to 1, 3, 5, 7, 11. B minus A is a set that contains 2, 6, 8. And A intersection B is equals to 4, comma 10. Then the set A is equal to. Okay. So it means it is given A minus B is this set 1, 3, 5, 7, 11. It means these elements, suppose A and B, these are the two sets. Let this be A, let this be B. And these elements belong to A but not to B. Right? It means they belong to this part. They belong to this part. Okay. So what can we say about this? This is 1, 3, 5, 7, 11 are in this P section, which is part of A but not of B. Similarly, B minus A is equals to 2, 6, 8. It means these elements belong to B but not to A. Okay. It means they belong to this C. Let me change the color and show. Okay, so this is 2, 6, and 8. Now, A intersection B is separately given as 4 and 10. Okay, it means this one. So this is going to contain 4, 10. Now they ask set A. So what is set A? We can very easily say this complete set, right? So what does that mean? A minus B union A intersection B, right? This set will give us set A. That is 1, 3, 5, 7, 11, and we have 4 and 10. Okay, so 1, 3, 5, 7, 10, 11. Okay. An empty set is denoted by phi. Consider the following statements. A, which says 5 belongs to phi. And B is a statement which says phi is a subset of phi. Now we have to decide which of the statement is true and false. Okay, so pi means it is a null set, a empty set, null or an empty set. Okay, so pi means it has no element. Pi means it has no element in it. Okay, means no element in the set. Okay, then what does that mean? Can phi belong to phi? Can phi be an element inside pi? No, it's a contradiction. Why? Because pi is a set which has nothing in it. It is an empty set. It is a null set, right? Nothing is there in it. Even this is not a null set. This is a set that contains pi as an element, pi as an element inside it. Okay, so this is not equals to phi. Phi means nothing inside it. Okay, so phi does not belong to phi. Is phi a subset of phi? Yes, that can be said. So A is false, B is true. Let A, B be two sets and U be the universal set. Then A intersection A union B, the whole complement is. Okay, this is asked. So, okay, let's see in this manner. I'll show it through Venn diagram and then we can see through properties also. Okay, this is A. This let this be A and this be B and this be the universal set U. Okay, then A union B. What is A union B? A union B is this. This is A union B. All elements taken once, right? Now they are saying the complement of A union B. This, the complement means everything which is not part of this purple or violet line, right? So this is all A union B, the complement. And they are saying A. What is A? A is this one. Okay. And they are saying intersection between this yellow one and this green one. So we can very clearly see there is no intersection. Okay. Oh, was I not audible? Somebody has messaged. I don't know what is happening this today. Okay, okay, I'll repeat it again. No problem. Please make a note as soon as you're not audible. Make a note very quickly. Okay. Okay. So what can we see here? Suppose this is A, this is B, and this is the complete universal set. This is A, this is B. Now this purple one is A union B. It means this one, to complete this. Okay. Then we have to take the complement, this one. So what can we see? Everything which is not this. So this is the complement. Then we have to take A. What is A? This one. This one is A. Okay. And we have to take the intersection of this yellow one and the green one. So very clearly this is phi. We can also verify it through properties. How? A intersection. Let's see the complement of this. So this is A intersection, A complement intersection, B complement. Okay. This is the property we can see here. I've noted it here. A union B, the whole complement. When it is getting opened, this becomes A complement intersection B complement. Okay. So we have applied this property here. Then we will apply distributive law, which says this will go to both of them. This will give us A intersection A complement. And when this will go here, will become A intersection B complement. And this, okay, let me change the color. And this intersection is here, common. Okay. Now everybody knows A intersection A complement is always a phi. A intersection A complement, right? It has nothing in common with it. Is equals to phi intersection with something, and that something in our case is A intersection B complement, right? So we have to take intersection between phi and this, because phi is a set which has nothing. It is a null set, it is an empty set, right? So it will have nothing in common with whatever you take. It can not have anything in common with anyone, right? So this is going to be phi. Okay. Let n and r denote the set of natural numbers and real numbers respectively. Which of the following is an example of disjoint sets? A is equals to x such that x belongs to n and x is a multiple of 5, and b is equals to x such that x belongs to n and x is a multiple of 7. Then it is set of natural numbers n and set of real numbers r. S is equals to people having birth month January, and P is equals to people having birth year 1994. M is equals to x such that x belongs to n and x is an odd number. And n is equals to x such that x belongs to n and x is an even number. Okay. So they are asking for disjoint sets. Okay. What do we mean by disjoint sets? What are disjoint sets in common? So we can very clearly see in a similar manner that they will somehow have some common element, right? Which will be a multiple of both 5 and 7. For example, 35. So if we are trying to add, okay, let me draw it like this so that we can see it very clearly. So this will have five multiples of 5 and this will have multiples of 7. And this intersection will have multiples of both 5 and 7. For example, 35, right? And all the multiples of 35, right? 35 is the first number in the growing sequence. And that is going to belong to this intersection. So this is not a disjoint set. Why? Because we want disjoint sets which do not have any element in common. Okay. Then second is set of natural numbers n and set of real numbers r. So we can very clearly see n means all natural numbers like 1, 2, 3, 4, this is it, up to infinity, right? Which means n is a subset of real numbers. Okay, proper subset of real numbers. So this is also not disjoint because complete set is the part of this. This is like this. This relationship is like this. Complete n is inside R. Okay. Then third one is S and P. Okay, let me draw S and P. S is people having birth month January and who are born in 1994. So this is S, this is P. It is very obvious that this section will contain people who are born in January 1990, right? So this is again not disjoint pair of no, this is again not pair of disjoint sets. Okay. Now we are seeing M and N. What do we mean by M and N? M is odd, N is even. Of course, there is nothing in common in it. Why? Because either a number is even or it is odd. Either it is multiple of 2 or it doesn't have 2 as a factor in it, right? So it's not possible that it is both odd and even, right? So very clearly, this is a pair of disjoint sets. Okay. Then A and B be two sets such that mod A is equals to 10 and mod B is equals to 8 and A union B is equals to 14. Then mod of A this B is. Okay. So what does this M indicate? That indicates number of elements in it, right? So they are specifying themselves. So number of elements in A is total 10, right? Number of elements in B is total 8. But we have to understand this 10 and 8 is not part of this C section, right? It's not part of this C. It's this, it is complete. Okay, let me change the color, then it will be good. This is 10 and this is 8. So number of elements in this blue circle is 8 and number of elements in this violet circle is 10. And number of elements in total means number of elements in this much is 14. It means this is total 14, right? But there are 10 elements here, 8 elements here. What does that mean? 4 elements are coming twice. They are repeated. So what can we say about it? They belong to this section, right? And so very obviously we can say if this much is 4, this intersection is 4, like this, then how much is this one? How much is this part? Of course, this is 10 minus 4, that is equals to 6. Okay. And how much is this one? This is 8 minus 4 is equals to 4, like this. Okay. Then A disjoint B. How many elements are there in this one? This is equals to A minus B union B minus A. And we have to take the count of both of them. Okay. I'm solving this with Venn diagram and we'll do it with formula also in just 1 minute. Okay. I'll show that procedure also. So this will give us which two parts? This green part and this green part, right? So that is equals to 6 plus 4 is equals to 10 elements, right? Okay. Now let's go by formula. Okay. So number of elements in A union B is equals to number of elements in A plus number of elements in B minus number of elements in A intersection B. Okay. Then we can see number of elements in A is 10. Oh, one more thing. This is now this. So we have a statement as 14 is equals to 10 plus 8 minus A intersection B, the number of elements in this. So therefore, number of elements in A intersection B is equals to 14 minus 10 minus 8, right? Sorry, 10 plus 8 minus 14, that is 4. Okay. So what we can say now, this is this. Now we have to identify A, this B is equals to, I think this will not be visible on white, is equals to mod of A minus B union B minus A. So we have to identify the number of elements in set which is equals to A minus B union B minus A. How can we identify that? A minus B means elements which are in A but not in B. Means how can we identify this one? Number of elements in A minus number of elements in intersection. Union means we have to add. So number of elements in B Again, it is minus. That is minus number of elements in A intersection B. Or you can say B intersection A. That is the same thing, right? We can also write this as this. We have to write if you want a detailed description. Okay. So how much is this? Number of A is given equal to 10 minus. We just identified this value as 4 plus more number of elements in set B. That is 8 minus B intersection A. That is 4 again. So this is equals to 10. Okay. Number of elements in set S is equals to 1 plus minus 1 to the power n such that n belongs to n. N is a set of natural numbers, right? This is the universal definition of this. Okay, is or are. So we have to identify number of elements in this set S. And the definition is given like this. Okay. Okay. So this is 1 plus minus 1 to the power n. Okay. So now suppose what all values n can attain. N can be equal to 1, 2. It can belong to anything in the complete set of natural numbers. Like this. Right? So either they will be odd or they will be even. Okay. So if it is odd, this value will become minus 1. If it is even, this value will become plus 1. So this can only have two values, right? Either it is 1 minus 1, 0 or 1 plus 1, 2. 0 when n is odd natural number. This we have to write completely, right? This is the assumption that we have. Not the assumption, this is the base on which we are deciding the answer. So this has to be written completely. N is even natural number. Okay? So the number of elements in it. So it is this. Let A equals to a set which has three elements. Okay? One, this, and this. Then which of the following is an element of power set of A? Okay. What does this mean? There are three elements in A. One is number 1, second is set 1, and the third one is set 2. Okay? It has these three elements. Now we have to identify the power set of A. Now power set of A, this will have phi. Okay, this is a set which contains all possibilities. So that is phi, then 1, right? Then a set which contains this second element, that is set 1. Then a set that contains only third element, that is set 2. Then 1 comma 1, then 1 comma 2, then 1 comma 2, this set, then all the three elements. Okay. So which is very clearly which one can we identify as an element of this one? Okay. Then let U equals to 1, 2, 3, 4 ABC be the universal set and L is equals to 2, 4 AC be the subset of U. Then L complement is. Okay, we can very easily do it through universal Venn diagram. L is 2, 4, A and C. So 2 is done, 4 is done, A is done, C is done. What all are remaining? 1, 3 and B. So these are here 1, 3 and B. This is L and this is U. Okay. And L complement we are identifying means this one. So that is 1, 3 and B. Okay. Or you can also solve it through formula as L complement is equals to universal minus L is equals to 1, 2, 3, 4 A, B, C minus 2, 4 A, C. That is equals to 1, 3 B. Okay. Each student in a class of 100 plays at least one sport, football, cricket, or tennis. What? Okay, let's start doing it directly through Venn diagram. This is football, this is cricket, and this is tennis. And the total strength is 100. Okay, so that is 100 students in total. Okay, 40 play football, 40 play football, 30 play tennis. Okay, 15 play football and cricket. So this one they have identified as 15. So this is 15. Then 10 play cricket and tennis. This is 10. Then 8 play football and tennis. 3 students play all 3 sports. Find the number of students who play cricket. Okay. So this is 3. It means how much is this one? This is 10 minus 3 is equals to 7. Okay. This is 12. This is 5. Then this is, how am I identifying? I'm just subtracting them, right? This is 40 minus 5 minus 12 minus 3, right? Means this is the count of students who play only football, right? So that is equals to 20. This one is who play only tennis. This is only tennis. Only tennis is equals to 30 minus 8 minus 3 minus 10. Oh, sorry, the minus 7. And this is 5, not 8. So this is equals to 15. Now this is complete students 100 minus 20 who play only football, minus 15 who play only tennis, minus 5 who play football, only football and tennis, minus 7 who play only cricket and tennis, minus 12 who play only football and cricket, minus 3 who play all three. So that is equals to, this is 20, this is 20, 40, this is 50, 62. So that is equals to Now, what we want, they are asking who play cricket. Okay. So who play cricket means this complete. So how much is that? Cricket is equals to 38 plus 12 plus 5 plus 15 plus 3. Right? This is 15, 15, 30, 35. 35 plus 38. Okay. State if the following statement is true or false. A union B minus A intersection B is equals to A minus B union B minus A. Okay. What does this mean? A union B minus A intersection B. What does this mean? Let's see it through Venn diagram. Through Venn diagram, we can see A union B is this one, right? Now I am saying we have to remove A intersection B. Means this much we have to remove. So this one remains, right? And they are saying this is equal to, this is huh. So this is A minus B union B minus A. So that is part of A which is not part of B, union part of B which is not part of A, means this one. So how much is this? Is it same? Yes. One more thing, we can solve this through formulae also. I can show that through formulae. Just give me a second. Hmm. So this gives us at least one sport. Means football. Okay, everyone plays at least one sport, right? Everyone is playing something or the other. Then 40 play football. So F is 40. Tennis is 30. Football and cricket is 15. Cricket and tennis is 10. Football and tennis is